The next lesson is on polygons, and it's basically more specific information from that first introductory lesson. Okay, what you're going to need to know here is what actually determines these different shapes. What is it that makes them unique? Okay, so part A, it says triangles, quadrilaterals, hexagons, octagons, etc. These are common shapes all around you, but how can you tell the difference? How can you describe them? What makes them different from one another? Okay, so that's what we're going to talk about here. What are the characteristics of each of these shapes? Okay, a triangle is a polygon. Polygon just means many-sided figure. Okay, it's a polygon, and it consists of 3 sides, or 3 line segments. Okay, and those make 3 angles. So it consists of 3 line segments and 3 angles. Now there are different kinds of triangles. Alright, the acute, now we talked about an acute angle, now we're talking about triangles. An acute triangle has all 3, well, I'm going to say angle, all 3 angle measurements. All 3 angle measures are less than 90 degrees. Okay, so this is a triangle that we're pretty familiar with. You know, it looks something like this. Pretty standard looking triangle. Okay, the next one is an obtuse triangle, and what makes an obtuse triangle is one of the angles. One angle is greater than 90 degrees. Now, it can't have more than one angle that's 90 degrees because it won't make a triangle then. But if we think about this, let's draw an angle here that is more than 90. So this is an angle that's more than 90. And so then to make it a triangle, you would just connect it like that. Okay. A right triangle has one angle, and it has one angle that's exactly 90 degrees. Okay, so let's again draw that 90 degree angle, and then we can make it into a triangle. Okay, so those are the 3 types of triangles based on their angles. Now let's classify them based on what their side lengths are like. The equilateral has all 3 sides equal and all 3 angles equal. Okay, so an equilateral triangle will have, it looks something like this, and to show that I'm saying that all sides are the same, I would go like that. And then to show that all angles are the same, I would do something like this, where I put a little line for each of those angles, showing that they're all the same. Okay, the next triangle is an isosceles. This one has 2 sides equal and 2 angles equal. Okay, so if we draw 2 sides that are the same, these 2, the third side would be different. And then if you looked at the angles, these are the 2 angles that would be the same then, and this one would be different. Okay? Okay, and then a scalene. This one is all sides different, or you could say no sides the same, and then all angles different, or not equal. Okay, so let's make a short side, let's make a little bit of a longer side, and then even a longer side there. So in this case, I'm going to do this to show that each side is a different size. Okay? Alright, so that's classifying triangles. Let's classify the quadrilaterals now. This is a little bit more complicated. Okay? A quadrilateral, what is it? It's a closed. Okay, a closed figure just means it doesn't have like an opening. Like this would be open figure. Closed just means that there's no place that's not connected. Okay, so it's a closed, four-sided, 2D figure. Okay, and let's just put here a little characteristics. The interior angles add to 360 degrees. By the way, the interior angles of a triangle add up to 180 degrees. Maybe we should put that in here. Okay, interior angles add to 180 degrees. So if you add up the three angles, they always add up to 180. In a quadrilateral, they always add up to 360. Okay, so let's go to the one we're most familiar with first. This is a square. Okay, what do we know about a square? Okay, all sides are equal. Okay. Now, yes, all the sides are equal, but there's more to it than that. Okay. The opposite sides are parallel. Okay, so if I just erase the equals symbol, parallel, it would show like this. If I put an arrow like this and an arrow like that, that means those two sides are parallel. Okay, and those two sides are parallel. Okay? In a square, all angles are 90 degrees. Okay? So I could put those little boxes to show that these are 90-degree angles. And then it says the diagonals bisect at, the diagonals are equal. Okay, what is a diagonal? A diagonal, if we have a quadrilateral, a diagonal is the line that goes through the middle like this. Okay? So in a square, these two diagonals are equal and they meet at 90 degrees. Okay? Diagonals are equal and they meet at 90 degrees. Okay, so that's probably the shape that we're most familiar with. I'm going to go to the one right next to it, the rhombus, because this is a special square. Okay, again, it has the same characteristics of a square in that all sides are equal and opposite sides are parallel. So that's the same as a square, but obviously it's not the same as a square. What's different? Okay, well the angles aren't 90 degrees. Here we're just going to say opposite angles are equal. So if I look at my shape, first of all four sides are the same. Okay, opposite sides are parallel. Opposite angles are equal, so this one would equal this one, and then this one would equal this one. Okay, and quickly, what about the diagonals? Okay, the diagonals bisect at 90 degrees. Now what does that mean? That means they will cross, it forms a 90-degree angle, and each arm of the diagonal is divided in half. Okay, that's what that means. So if you want to put that picture here, okay, it's going to form a 90-degree angle, and this side will equal this, and this will equal this. Okay? The next shape that you're probably pretty familiar with is the rectangle. Okay, and using what we've written so far, let's try to describe the rectangle. Are all sides equal? No. Opposite sides are equal. Okay, opposite sides are equal and parallel. Okay, so for example, this side is the same as this, and this one is equal to that. As well, this side is parallel to this one, and this one is parallel to this one. Okay, what about angles? All angles are 90 degrees. And what about their diagonals? What do we know about the lines that would go like this? What do you think? Okay, well, about all we can say in this case is that the diagonals are equal. Okay, let's use this information then to do what's called the parallelogram, because the parallelogram is kind of like a rectangle. In fact, a rectangle is a special parallelogram. I didn't spell that right. There. Parallelogram. Okay, all we can say here is opposite sides are equal and parallel. But all the angles aren't 90. We just have opposite angles are equal. Okay, and again we can say the diagonals bisect. Okay, so let's quickly look at the two examples here. In the parallelogram, the diagonals will bisect each other. In the rectangle, they will do the same thing. They will also bisect each other, but in this case, each of these sides turns out to be the same. Okay, so those are probably the four most common. We've got a few more shapes here. We've got the trapezoid. Okay, trapezoid. The only thing we can say here is we have one pair of parallel lines. And if you look at this picture, this side is parallel with this side. There's no equal sides, okay? Just the opposite sides are parallel. Okay, can't say anything about the angles, can't say anything about the diagonals. Alright, and the last shape is the kite. Okay, here we have no parallel lines, but we have two pairs of equal sides. And if you look at this shape, this side equals this one, and this one is the same as this one. Okay. What about angles? Well, usually there is one pair of equal angles. And you should be able to see that the angles that are going to be the same are here and here. Okay, and then what about the diagonals? the diagonals intersect at 90 degrees. Okay, so that's a lot of information to process. What I would do maybe is put some of that information on a cheat sheet. That might help you out a little bit if these questions show up on a test. Okay, let's go to the next section. Regular polygons. Okay, what's a regular polygon? Again, it's going to be a closed figure. Where all sides are equal. Okay, and then so all sides are equal in length, and that means all of the angles are going to be equal too. Okay, so let's go through this pretty quickly. We'll just do this in order. Pentagon is 5 sides, hexagon 6, heptagon 7, octagon 8, and we have 9, 10, and this is not in order now. Dodecagon, this is 12, and I don't even know if I can say this one. Icosagon, there's 20. I don't think you're ever going to need that. That's maybe more for your information. Okay, so let's examine what we know then. If we know these are regular polygons, we're going to be able to know a lot about the measures and sides based on that. Okay, so in an equilateral triangle, equilateral meaning all sides are the same, we have 3 sides. Okay, there's just one triangle, obviously. The sum of the interior angles, well, a triangle, the angles always add up to 180 degrees, and since it's an equilateral triangle, I'm going to divide this by 3, and then each angle would be 60 degrees. Okay? Now let's look at the next one. A square. A square has 4 sides that are the same. Number of sides is 4. Number of triangles. Well, what do we mean by that? Well, this means if we divide it in half like that. Okay? There are 2 triangles. And the reason we just divide it in half is because we want to look at each of these shapes in terms of triangles. Okay? That means if there are 2 triangles, it would be 360 degrees. And since there are 4 sides, I'll divide by 4. That means each angle is 90 degrees. And we already know that about a square. Okay? Let's look at the pentagon. There are 5 sides. How many triangles are there? Well, I want to divide this into some triangles. So I'm going to put 1 there. This here is not a triangle yet, so I'm going to put it there. I now have 3 triangles. Okay, so if I go 3 times 180, I get 540 degrees. That's how many degrees will be inside a pentagon. And if there are 5 sides, if I divide by 5, I end up with each angle being 108 degrees. Okay, so what that means is each one of these angles is 108 degrees. Okay? Let's try the same thing here. We'll divide it into some triangles. So I see 4 triangles. So it's 6 sides, 4 triangles. 4 times 180 means I have 720 degrees inside a hexagon. And if I divide that by 6, each angle is 120 degrees. Okay, and this actually gives us a formula. Okay, and the formula is on the next page. The formula for the measure of each interior angle. In other words, this. How do we get that? Okay, the measure is 180 degrees times n minus 2. Okay, what's n? N is the number of sides. Okay, and then we're going to divide by n. This is the measure of each angle. So for example, if we did this one that was just up here, a 6-sided figure, the regular hexagon, what would be the measure of each side? We would go 180 times, well, there's 6 sides, and then divide by 6. Okay, and what does this equal? Well, what do you know? It's 120 degrees. Okay, so this works for any sided figure. Okay, and another formula that you're going to know, or need to know, is the formula for the sum of the interior angles. So this is for one angle. This is for all of them. Okay, and this formula is 180 times n minus 2. The nice thing is these formulas are pretty similar, and you can put them on your cheat sheet as well. So let's try a question. What is the sum of the interior angles of a regular heptagon? Uh-oh, we need to know how many sides that is. This is 7. So the sum will be 180 take away times 7 minus 2, right? That's our formula. Maybe I'll write the formula first. So you'd get 180 times 7 minus 2, and so the sum of all the angles would be 900 degrees. Okay, how big is each angle going to be? Well, remember the measure formula was 180 times n minus 2 over n. So this would be 180 times 7 minus 2 over 7. And if we put that in our calculator, I end up with 128.6 degrees. That's the measure of, so if we were to draw a regular 1, 2, 3, 4, 5, 6, 7. So there's a regular 7-sided figure. That's a heptagon. That means each one of these angles is 128.6 degrees. All right. So you have an assignment here. Please do that. And we'll stop there for today.